last section. Quadratic inequalities. Let's just review a little bit on quadratics, okay? When we're graphing quadratics, what do they look like? You should know this by now. A U. Well, they look like a parabola, whether it's like this or like this, okay? Whoa, we're really delayed. Gee. A parabola, quadratic. And inequality, what does that word mean? Inequality. It's crazy. Inequality, what does that word mean?
Not equal.
Not equal. So if it's not equal, what is it?
Not equal. Just kidding, I'm confused.
What if it's not an equal sign?
Oh, greater than, less than.
Yeah. It's greater than, less than, greater than or equal to, less than or equal to. Those are the different inequality symbols, okay? And what do you do when you have an inequality symbol in your graphing? You end up shading, right? You end up shading things, okay? All right? So, what we are doing is we are either shading like inside of the parabola or we're shading outside of the parabola, that type of thing, okay?
What? Who wants to shade outside of a parabola? That's not fun.
Okay? The inside part is the more interesting part, okay? Graphs like this are used in like supply and demand curves. I don't know if any of you guys are in economics, but supply and demand curves, maybe it has like a parabolic supply demand curve, and then you're trying to figure out how many products that you need to supply in order to meet the demand.
So
right?
when the demand's coming down and
Yep.
the supply's going up,
Right.
You got to find that space so you know when to peak and when to go down.
Right. Because you want to supply the most amount to meet the demand so that you're making the most amount of profit, right? Okay.
Mm-hmm.
So you're trying to find that threshold where you're making the most profit, okay? So, step one, graph the related functions. So we're going to graph these just like they're equal signs. Graph them just like they're equal signs. Step two, test a point in the parabola. I'm going to show you a way to cheat those so you don't necessarily have to test a point. We'll talk about that. And then shade accordingly, okay? The one thing that you need to make sure of is whether it's a solid line or a dotted line, because I screw that up all the time. So I did the 6th period too. So keep those things in mind as we go through. We're going to graph these just the same as we've always done, all right? So in example 1, we want to graph this function. Just treat that like it's an equal sign, and we want to do the vertex first, okay? Well, it's been a while since we've done vertex, okay? We're going to do vertex, we're going to do the zeros, and then we're going to do the y-intercept also. So those are the 3 things that we're going to look at. Those are the 3 easiest things to look at. Then we should be able to come up with an equation or a graph of what this thing looks like, okay? So, do you remember what the negative b over 2a for vertex, negative b over 2a. That's my formula. How do I find the y coordinate? Plug it in. Okay? Plug in. So I'm trying to find that vertex. I'm trying to find the high or the low point, right? And is this one going to be smiley face or a frowny face? He's going to smile, so he's going to have a minimum value. He's going to smile. I don't know. There we go. You can't see it now? Exposure down?
No, I was joking.
Oh boy.
That's beautiful.
Happy medium right there.
There we go.
Right there. Beautiful. Okay. Okay, so negative b over 2a. What's your b value, folks?
Okay.
It's what? It's 2. So we have negative 2 over 2 times 1. Negative 2 over 2 times 1. And that is negative 1 when you simplify. Okay? So we're going to put negative 1 in this spot, and we need to plug in to find that spot. Okay? So, negative 1 squared plus 2 times negative 1 plus 1. Okay. Somebody in the 6th period class, again, screwed this up. Negative 1 squared. They plugged it into their calculator. Negative 1 squared, and it said negative 1. It's 1. It's positive 1. Negative times negative makes positive. So when you type that into your calculator, either use the parentheses or don't put the negative because it's going to end up being positive. 2 times negative 1 plus 1. So what's the answer? 0. So my vertex is at negative 1, 0. Uh-oh. That's a little bit of a problem because my zeros is the next thing that I'm doing, but I already found my zeros. So how do you normally find zeros though? If you're looking at this equation right here, x squared equals 2x plus 1. That's a simple trinomial. What can you multiply to get 1, but when you add them give you 2? What can you multiply to get 1, but when you add them give you 2? 1 and 1. X plus 1, x plus 1, right? So if I set x plus 1 equal to 0, then x equals -1. -1 is my intercept, right? We already know that, right? But for future reference, because you won't always have an example that's like this, for future reference when you're doing those zeros, go ahead and figure out what can you multiply to get this number, well, when you add them give you that number. And that will give you your zeros. Okay, so I have 1 point to work with. And I have nothing else to go off of except the y-intercept. Where does he intercept the y-axis? This number tells you right here. This number is your y-intercept. Okay, use him to your advantage. He's going to intersect the y-axis at 1. But if he's doing that on that side, then he's also going to intersect at 1 over here. He's going to be symmetric, right? And be over there. Ooh. And there we go. Okay? Ah, crap. I did it again. Y is greater than.
Oh, we got a shade.
It's going to be a dotted line for starters.
No.
A dotted line for starters.
No, we're
Just
not
make yours
joking.
like mine. Just make yours like mine. Okay, now, big controversy, 6th period. Do we shade inside the parabola or outside the parabola?
Outside.
Inside, because
No.
everyone else said outside.
Now, here's how you know y is greater than. It says in the equation y is greater than. If I take that parabola and I fold it down just a little bit, what's greater than? Above, right? So if I fold that parabola back, it's going to be the inside part, right? If I fold that parabola down a little bit, okay? If I take this parabola and I fold it down a little bit,
Wait, so
I got it right.
it's going to
just
be
off the
above,
sheet.
greater than is above. It's going to be inside. Yeah?
inside?
Greater than's inside. So we shade.
Yeah.
Shade like that. That's greater than. That's above. Right? That's greater than. That's above. Okay? Yes.
Eric, I told you I was
Unless
right.
it's pointing down.
I'm gonna stop.
Unless it's a parabola pointing down.
Do it,
Okay? We'll talk about that here in a second.
Let's go.
So there are 4 different scenarios that you could have. 4 different scenarios. You could have an example that looks like this where you're shading inside, you're shading outside, you're shading inside, you're shading outside. Those are the basic 4 different scenarios that you're going to have. Okay? Either it's a smiley face and you're shading inside, smiley face shading outside, frowny face shading inside, frowny face shading outside. Those are the different things that are going to happen, okay? And these, again, are like those supply and demand curves. So, like, supply and demand, if you look at this one, supply and demand, I want to figure out, here's a really good example, is advertising. All companies have to advertise, right? At some point in some juncture, right? They have to advertise. Like Nike does advertising, okay? They choose really sketchy people to do their advertising sometimes. But they do advertising, right? But at some point, they have to figure out,
I had to watch you guys.
at some point they have to figure out how much money are we spending on advertising? How much money is too much money that's taking away from our profit, right? So they're making money, but at a certain point, they're not going to be making money anymore if they spend more money on advertising, right? Yes, sir.
Okay, so Nike, how come they increase their profits when they make Colin Kaepernick replacing the company?
I don't know.
Because the liberal liked that and they paid for it and bought Nike. And all people that burned their Nike apparel went out and bought more Nike.
I don't know. I don't keep track of all that stuff. But anyway, this is kind of like advertising, okay? Or like supply and demand curves, all right? So down here is another example. Example 2, solve by graphing. They want us to graph this thing. Again, we're going to start with the vertex. We're going to do the zeros. And we're going to do the y-intercept. Vertex, zeros, y-intercept, okay? Now, negative b over 2a is the zero formula. Negative b over 2a. I want you to go ahead and do negative b over 2a for this function. So, I'll give you a 30-second head start. Negative b over 2a. Do that. Negative b over 2a. Calculate it, plug it back in. If you need a calculator, go for it. Figure out your negative b over 2a. what I got. Negative 1, negative 9. Yeah? Negative 1, negative 9. And you plug it back in, you get negative 1, negative 9. Okay? Which is a little bit off the graph, whatever. Put it down there somewhere. Okay?
It costs a lot.
Now, we did find the zeros. What type of function is this? What
It's
type
the
of
one
function
that
is
faces up.
It points up, right? X squared plus 2x plus, or minus 8. What is he? He's a trinomial. He is simple. We can multiply to get 8. Negative 8, but when I add in, give me 2. 4 and 2.
Negative 4, negative.
Okay, we'll figure out 4 and 2. X, 4x2, okay? So we want them to add together to be positive. So which one has to be positive?
4.
The 4 has to be positive, right? 4 has to be positive. But then when I do x plus 4 equals 0, the 4 is actually negative when I set it equal to 0, right? And then I do x minus 2 equals 0. So x actually is equal to positive 2. Okay, so plot those 2 points. Negative 4, positive 2, and I'm not going to make a mistake again.
Dot.
It's a dotted line, right? Because this guy tells me dotted. Dotted. Okay? Oh my god. You're seriously? I just said that. I just said that. I quit. I quit.
No
Oh
more
my
math.
god.
Yay.
I just said that I was going to do dotted. I just wrote it down. How did that even happen? I don't even know.
I didn't.
That's good memory.
So I said, yay, the only school in America with
Okay.
no math class.
Now, we need to figure out whether this is going to be shaded above or below.
Whoa.
So y is greater than this. Y is greater than this.
Oh, you got shade outside.
You're going to shade inside.
Oh,
You're
okay.
going to shade inside. Y is greater than. Y is greater than. Greater than, again, is above. If you would take that parabola and fold it down a little bit, above would be up, right? What?
It really makes no sense.
What?
Your whole, you fold it down.
Like if you
It
take
makes
these
sense.
things,
No,
if you take these things and bend it down, okay?
Greater than.
Forget I asked.
So if you take those things and bend it down to make it like a wide parabola, right? Above would be here. Now fold it back together. Above is inside. That's how I think of it. I don't know. My brain works
Greater
weird.
than is always higher.
Okay, now,
No,
greater
I
than
got
is not
that.
always inside.
That's what you said.
No,
When
that's
it's-
not what
Besides
you
the
said.
negative.
When it's up, if it's pointed down, greater than is above. Right?
Oh.
You're
Oh.
just confused. Okay,
Mind
well,
blown.
write this down.
Mind blown.
No, that's not
Oh,
what you're
now it
doing.
makes sense.
Okay.
Above. Gotcha.
Alright.
Now,
Okay, Cody's got me. Alright.
One pause.
Flip to the backside. One more.
How you doing, Cody?
One more of these. Okay. Vertex. Zeros. And y-intercepts. Okay. I didn't even use the y-intercept on the last one because I was able to figure out what he looked like with my zeros, right? This guy, which one is going to be weird or not so much fun to find with this guy?
Oh, the zeros.
The zeros. Why?
Uh,
He's not a simple trinomial, right? He's got a 2 in front, okay? So maybe we'll find the zeros, maybe that we won't. I don't know for sure. We'll try and see. We might not find the zeros if we have enough information with the other 2 things to figure out what he looks like, okay? So you can omit some information if you want to. But we do need to find the vertex, so negative b over 2a, go. Find him. Negative b over 2a. Figure it out. Negative b over 2a. Negative b over 2a. Who was in Spanish this morning, first period? Anybody? Anybody? Nobody? Mr. Carl had a really, I think it was Mr. Carl, had a really explosive, like, sneeze. It was like, I was like, well, better that than, like, holding it in. You, like, burn brain cells when you, like,
you don't burn them.
You can
they die. They, like, yeah. You can have an aneurysm that way and die. You can die from a sneeze. Did you know that? Whatever.
If you hold it, if you plug it.
If you hold it in, that's bad. Don't do that.
You wanna try it? What? How's it negative 1?
Is it -1?
Yeah, boy.
I thought it was negative 2. No.
Hey, because 2 times A is 2.
That equals -7.
Yeah, but 2 times 2 is 4.
Yeah, so it's -4 over 4. 4 divided by 4 is 20. Okay. So this is 1. 2 minus 4 minus 5. Okay. You got -2. You got -9, right? Yeah, you got -9. -1, -7. That's your point. So plot him. -1, -7. Okay. Now, let's figure out what our y-intercept is, because I said we didn't want to do the other one. We didn't want to do the zeros. What's the y-intercept? -5 here, and he's going to be -5 there also. So he's going to go like, I'm safe. I'm safe.
Oh, it's actually
I'm
not
safe.
six
It's
times.
finally equal to. It's finally equal to, and I can do a solid line. Ah. Okay.
But
Now.
it's greater than.
Y is less than. Read it backwards.
Oh.
Y is less than.
So it's.
Y is less than.
So it's outside.
So it's outside. It's
Okay,
outside.
But when it's the other way around, when it's an upside down, it's inside.
It would be inside.
Yeah,
Confusion. Huge confusion.
Alright, let's just go to the home.
Huge confusion.
No, Cody.
Hey. What?
Cody, we still have more examples.
I don't know. We don't.
I don't think so.
We don't. I didn't figure it out.
Are we done?
All right, no, couple more. Solving a quadratic inequality using a calculator. I am going to give you this.
Desmos.
Desmos.
Oh.
Yeah, no.
Desmos. Hold on, I gotta get rid of some crap. This
Only
is
like
my-
4,000.
there we go.
Yeah, no.
Okay, so your problem over here says this, okay? We are throwing water balloons, and we want to hit a plane in the face back there. I want to throw a water balloon in the air and hit a plane in the face.
Has to be a straight line though.
Now, I'm going to throw it into the air, and it does have to, at some point, have like a little bit of an arch to it, right? Okay?
No.
Even like when you throw a softball or a baseball, it still does have ever so slightly of a parabolic arch to it. Yes, it does.
Come on.
Yes, it does. It does.
You throw it straight, you throw it fast and you
Nope,
straight
nope,
down.
nope. It still does this a little bit. Just ever
So
so
even
slightly.
when you chuck it
Just
straight
ever
at the
so
Straight
ground,
slightly.
line and just drop.
So when
is
you-
what it does.
when you're chucking it straight at the ground, you're saying that it has to go like this to hit the ground.
Okay, maybe more so softball than
Exactly.
baseball. 'Cause it's going up.
Softball, you have to
Okay.
softball.
It's going up in the dip.
Baseball's
All right,
just
whatever.
straight.
No, I can put it.
We
I don't know. Anyway, so we want to throw a water balloon. We want to throw a water balloon that's going to land on the plane's face back there, okay? So we want it to do this. Here is me throwing the water balloon. It's going to go up, and then it's going to come back down, and it's going to land on McLean. Splat, okay? So this is the function that is my parabola for the water balloon, right? That function that's listed in the paragraph is my parabola, okay? I am going to graph that on Desmos.
Good thing we did it, bring our computer.
Okay, this is what he looks like. Woo! I launched that puppy in the air. We went, and we have to go outside to do this because I'm up in the rafters here, okay? So I launched that up in the air. We want to figure out, okay, not only is McLean sitting back there, but he's also sitting on some sort of platform which is 3 meters above the ground, okay? Did you read that? We want to know what time will the water balloon be within 3 meters of the ground, okay? So I want to know when it's going to hit over here at 3 meters above the ground, okay? 3 meters above the ground is down, let me zoom in, down here when it's 3 meters above the ground. Here's 5 meters above the ground, so I want to know when it's going to hit down here, okay? 3 meters above the ground is about there-ish, okay? How many seconds does it take that to happen?
About 6.
About 7.
6.8. That seems like a long time.
7.
but I'm launching that thing way up in the air. 6.7, 6.8. It's going to take approximately 6.8 seconds in order for it to be 3 meters above the ground and hit a plane in the face. Okay?
Are we gonna have to use bezels on the
I don't think so, actually. I don't think so. I don't know for sure. I don't think so. Okay? The last one is, you don't use Desmos for this last one, but you do have quite a few problems that are like this. We want to solve this one algebraically. Okay? I don't want to have to graph every single one of these darn problems. I want to solve this algebraically. So what we do here is rather than shading it, okay, you're going to have regions like, let's say x is less than 4, or -2 is less than or equal to x, which is less than or equal to 9. I don't know. You're going to have regions like that. That represents a shaded area, right? X less than 4 is a shaded area, okay? X between -2 and 9 is a shaded area. So what we're going to do is we're going to solve this thing algebraically, but there's a problem with the way it is situated right now. You need to move the 18. McLean, shush. You need to move the 18 to the other side. -18. So x squared minus 3x minus 18 is less than or equal to 0. Okay? So now we've got to set up nice and ready to go. These 3 pieces on this side. This is a simple trinomial. Okay? What can you multiply together to give you -18, but when you add them, give you -3?
Oh, what is it? 6 and -6. 6 and -6. 6 and -3.
Okay? Now, I want them to add together to be -3. So which one has to be negative? The 6 needs to be negative. -6, +3. Okay? Now, when I set those equal to 0, x minus 6 equals 0, and x plus 3 equals 0. Okay? X equals +6, right? And x equals -3. Okay? Now, to get an inequality, to figure out the shaded region, okay? My trig and calc kids are just got done doing something very similar to this. And they call these numbers right here critical numbers. We will call them critical numbers also. They are critical numbers because important things happen at those numbers, okay? 6 and -3 is like where everything else is 0. So 6 and -3 are my critical numbers. Those are the important spots, okay? Now, I'm not going to shade this, or I'm not going to graph it at all, but I am going to do a number line. So I'm going to do -3 and 6, okay? What?
No,
No,
box
no.
and Mr. Box.
-3 and 6. Now, God bless Trent Court. I had him last year in math and the year before that in algebra. So 2 years ago, he used to do this in algebra, okay? Trent Court. And it scarred me for life. I'm like, where did I go wrong as a teacher? So he's sitting here, getting ready, he's doing all this, and he's doing this thing.
Oh my god.
I don't know what your number line looks like, but mine goes in order. I don't know. And then we started getting like 3 numbers in there, and he's like, yeah, let's go. Right? Like, come on, help me out here, put her in order. So anyway, don't do anything traumatic to me like that, right? Don't do that to me, okay? So put them in order, please, okay? Now, once you get your critical numbers, very last step, okay, very last step, we want to test a point to figure out if this region is the answer, if the middle region is the answer, or the right region is the answer. We want to figure out which one works, right? Okay? So it's either going to be the middle region or the 2 outside regions, okay? Middle region or 2 outside regions. So what we're going to do is we're going to test the very, very, very easiest point you can plug in.
1.
0.
0. Always plug in 0. Now, 0 lives right here. Will 0 always live in the middle? No, right? If my intervals are all over here, 0, we're still going to plug in 0 though, okay? So plug in 0. 0 when we plug into this top equation up here. We are going to see right here, I do 0 squared minus 3 times 0 minus 18. We want to figure out if that's less than or equal to 0. Okay? Figure out if that's less than or equal to 0. Well, 0 squared minus 3 times 0 goes away. So is -18 less than or equal to 0?
Less than.
Yes, it is. Yes, it is. So the region that I want is -3 and 6, right? This is no good, and this is no good. Okay, we only have to test 1 point to figure that out. So the region, basically, this is like saying, if I had my parabola, it would be shaded on the inside, right? Instead of on the outside of my parabola. This is basically like cheating and saying that. Yeah? So to write your answer, you're going to write it like this. Watch this very closely. -3 is less than or equal to x, which is less than or equal to 6. That is how you will write your answer, okay? In that chunk. Okay? Does that make sense? This is like shading. If I were to draw a parabola on here, it's like shading the inside of your parabola, right? That's basically like what we have found, okay?
What if it's outside?
Okay? If it's outside, so if this did not work, if this didn't work, you basically would have two regions. You would have x is less than or equal to -3 and x is greater than or equal to 6. You're going to write them as two separate pieces. Does that make sense? If you're shading on the outside, you're writing these guys here. X less than or equal to -3, x is greater than or equal to 6. No. Then this would have been the answer. Yes? If it was positive 18, this would have been the answer. Okay? Plugging in 0 is a very nice number because then you can just compare the 18 to the 0 on the other side. That makes it really nice. Does that make sense?
So is your
So
0 your X or
algebraically
your
doing
Y?
this is very easy. What?
Is 0 your X or your Y that you plug? So you plug in.
You plug it in for
X.
Yes.
So then, on the far right side, though, is still Y. Or right there, you got -18 is less than or equal to X or Y.
This is just the original equation. Right here.
I got that, but like.
Yeah.
but
That's
how do you-
basically like your y, yeah?
Your original equation is, or the 0 on the end?
The 0 on the end is like your y.
Yeah.
Yeah, basically, yeah. If you want to think of it that way. Okay. Now, Erica Boyd, if you get confused on which region to shade, are you ready for this? If you get confused on which region to shade, just plug like 0 in and see if it works, and that will tell you where to shade. Does that make sense? If 0 lives inside, right? The parabola? 0 lives inside the parabola. So if you plug 0 in here, does that end up being less than 0? Okay, so that works, right? So we're going to shade that, right? If I plug 0 in, -8 is indeed less than 0, right? So that works, so we're going to shade the inside, yeah? Okay? So, if you get confused, just plug in a point. Make sense? Good? Great.
Yep, that makes sense, I guess.